Hello, and today I will be doing lesson 4 by FJLJ. Again, awesome YouTuber. So this is the challenge. If I run it, enter username, with something at serial, it says keep edit kiddo. So let's throw this into 32 dbg and see what we've got. So first thing I'll do is just run it again. Username, serial, it says keep edit kiddo. So I'm gonna start off by all modules, string references. I could also look at intermodular calls, but we'll start off with string references. More search, keep at, and we get nothing. Enter, nothing. Username, nothing. So there's nothing interesting there. So let's look at intermodular calls. Okay, so we would want, it's a console application, so maybe printf, nothing there. Scanf, gets. Yeah, we're not really finding anything, so there's not much luck in here. I've actually done this before, and when I looked at it the second time, I think I realized something, a place where you could start off by looking through here, but I won't be doing that for this case. I'll just show you the method that I did get some hits from. So if you go into view symbol info and you go here msvcrt, and then in here you type in printf, so we get printf here. This is also the same as just going into modules and msvcrt. I think msvcrt is like the standard library kind of thing, which has the printf functions and the scanf functions and stuff all inside of it. So it's like, I've not really done any C programming in Windows before. But in Linux, if you do include stdio and things like that, you get the standard library functions, stuff like that. So scanf, printf, gets, and then the stuff to do with pointers and things like that. So anyway, we see that there is a printf here and it's being pushed, and so if we just put a breakpoint on the return point, so I think the way that it will be called is this function will be referenced every time the program would like to print something to the screen. So rather than doing call to printf, it would do a call to this function which will load printf and do stuff, and probably put into register, and then it would be a call to register from the caller function. Anyway, another thing to look for would be scanf, and we see there's a scanf right here, so we could do this. Oops, I went on something else. I meant to go on scanf. So here we'll put a breakpoint on scanf return, and let's just rerun the program. Okay, so you see that our fast breakpoint gets hit, and if we hit F7, which is to step into, we see that it was called as EAX. So as we guessed, it was called as a register rather than a call to printf directly. Okay, so yeah, so this is, we could put a breakpoint here, and then you could imagine this would be the same thing. And this is the point that I was talking about. In intermodular calls, I think you do see flush, and if I'm correct, flush is used to clear out the buffer after a user enters some input. So in here we do see flush, and if you know what flush does, then you can just double click that and it brings you to this point. Okay, anywho, we will set some breakpoints in here, and then we could remove these two breakpoints, so just disable them, and let's just restart the program. We hit our fast breakpoint. If we step over, it will F8, and then it will actually print it, so the printing occurs inside of there. And now it's expecting some input, so enter some stuff, and I don't think I removed that breakpoint. Anywho, F9, it'll print something else, F9, F8, okay, and then let's see, so after this, actually, I think if it's referencing some function to get the printf, then we would like to keep the breakpoint in there to see where it's being referenced from when we get the failed message. So I'm gonna just go back into modules and then look for printf. It's this guy here, and I'll just set a breakpoint there, and then we will continue. We just need to put enter there. So here we see it prints keep edit kiddo, it's our breakpoint. If we do F7, so this will be the function that will print the message, keep edit kiddo. And at this point, you know you know what you have to work with. It's gonna be this stuff here, probably these function calls here, probably something to do with this address here, wink wink. So let's remove these. Let's remove, oh damn it, I pressed F1. It's gonna give us some whole like documents and stuff which we don't want. So let's just remove these breakpoints here, because we have got we've got breakpoints on these, and once we've put our input in, we know it's gonna come directly here. You gotta jump, and then you've got some stuff here. This is probably another printf. This is a printf, and I think so we get EAX, put EAX into EBP minus 2C, and put that back into EAX, which doesn't make much sense to me, because we're putting EAX into EBP minus 2C, and then we're putting that back into EAX. EAX would already equal that, but okay, and then we're putting EAX onto the stack, which will probably be used as an argument for this function. And then once we get the result of that function, we put it into EDX, moving this thing into EAX. I suppose this would be some area in memory which would have been manipulated by either this function or somewhere else within the program, because it should store something of some significance if it's being put into EAX near the validation part of the program. Anywho, after that we do XOR EAX EDX. Then we put this thing, which is another thing that should have some significance. We move that into EAX. We see it being referenced here, right after this call, we see it being referenced. And then here as well. So you move that into EAX, and then this part of the code is kind of like a reference to some array. So when you're referencing an array in assembly, you'd have the base address plus the offset plus the size. Size being 1 if it's a char, 4 if it's an integer, I think, and more if it's some other things. So it's basically like the base plus offset plus the size, and that's being put into EAX. And at this point, EAX would contain whatever is in here. So it'd go to like, so this address, this value would have some significance. And at the moment, you could see, well, the program's already being run. At the moment, it's 3. You can see that here. Or if we follow in dump and we go here, we see that it's a 3. And then if we go here, if we follow this and dump, it's giving us some random stuff. Well, I would imagine it would give us keep at it, kiddo. 1 sec. I'm just getting a phone call. So. Just 1 moment. I know I should probably edit my videos to make them shorter and to make them concise and straight to the point, but maybe I'll do that in the future. But okay, what was I? So heap at kudo should be inside of this address because we see it here, and removing EAX. So basically, whatever is at this address gets put into EAX, and EAX goes into the stack, and then we move this, which we could see is printf into EAX, and then we're calling printf probably with whatever was here as the argument, because it gets put into EAX, and then EAX gets put into the stack. So what we would want to do, or like at least from seeing this, we would want to identify where the correct message is, and we could potentially manipulate EBP minus 2c to equal to a value which would redirect this to the success message. And that's probably what we will do, but we will try and see what happens in here, because we know that the result of this function goes into EAX as the return value, and EAX gets put into here, EBP minus 2c, and EBP minus 2c is has a significant part to play in this validation. I've got a sore throat, but never mind that. Let's see. Let me try and rerun this program, and then once we get to this function call, let's see what this function does, and then maybe we could see what this function does, if it has anything, if it changes anything. Let's see. So rerun the program. I could just X that and run it, and we don't need that breakpoint anymore. John, haha. Alright, so let's F7 to step into this. Damn it, go away. F7. We'll put a breakpoint, not there. Okay, let's see. Move on to AL, GMP, SJE. Okay, so let's just F8 for now, and let's see what the syntaxis jump after that. Move 0 into AL. Okay, so we see a deck EAX. Let's see what this value holds. This value holds a 3. So I think we don't want to have a 3. Let's come out of this function and see. We don't want to have a 3 because on the last time we ran the program we had a 3 and it resulted in the error message. But let's just see what happens. So EBP minus C will be a 3, then we add that to EAX. EAX is a 3, clean the stack, returning. We have 3 being put into here, even though this, okay, and then we have 3 being put back into EX. I still don't understand why that is there and what that does exactly. EX goes into the stack, and we're calling this function with a 3. Let's step into put a breakpoint on this return. We will see 3 being moved into AX, and that would happen if this jump isn't taken. Let's put a breakpoint there, F9, F8, so we see 3 is being put into AX. And then 3 gets put into EDX, and this thing contains 3. So I could tell you from looking at that changing the value of AX in there wouldn't matter too much because this thing already stores 3 inside of it, and I think it gets the 3 from here. So I don't remember what the value of this address was at this time, but then after you decrement, actually wait a sec, it jumps over that, yeah. So let's see, is it referenced anywhere else here? So doesn't take that jump, but we'll keep at it kiddo, and let's see if we follow this and dump. No, I went past it again. Okay, I'm gonna have to retry this. goodness. I'm guessing I went past it again. Okay, I'm just gonna have to put a breakpoint there. Goodness sake, what am I doing? Okay, so here we see we have the keep at it kiddo failed message, then we have it says pause, and if you go up just above it, it says you did it. So we know that EAX, which is being used as a way to reference this portion of memory, needs to be changed in order to reference this portion of memory. So we could do that by changing EAX to 2, and we know that by looking at the memory. And so if I redo it and I say FJLJ, and then I F7 into here, and we see there was a portion in here which would decrement EAX, and then put EAX into this address, and then decrement this, which is 3 when it by the time it comes down here. So basically it changes everything from 3 to 2, and we could do that by changing this to JNE, because by default it will jump over. Otherwise we could just change this to JMP, and then the instructions right below it will occur. Otherwise we could maybe just knock it out, but actually let me just grab the address of this. So copy address, and then we're gonna go not gemp, my friend, GMP OX, that address. Okay, and it looks kind of stupid, but it jumps to the instruction right below it, F9, and you can see instantly it says you did it. And what do we have? We have an instruction, so we have the program saying that we did it. So for me, the things that I learned from doing this program was identifying the starting point, and then learning a little bit more about the way that memory is referenced. Those are the big takeaways for me from this lesson. Thank you, FJLJ. You're an absolute legend for making these challenges. Much love from my channel to yours. Anyway, I'm gonna wrap it up there. Goodbye.